So I want to get into some new log properties that we haven't used yet. But first, let's back up. If we had x to the 5th times x to the 3rd, we go x to the 5 plus 3. That's how exponents work, right? If I had x to the 5th divided by x to the 3rd, that's going to be x to the 5 minus 3. And then the other property, if I had x to the 5th raised to the 3rd, then I go 5 times 3. So quickly, multiplication, the shortcut was to add the exponents. Division was to subtract. Raising an exponent to another exponent is to multiply, right? So what's the significance of that? Well, anytime you push the log button on your calculator, you get an exponent out, right? So here's what comes from that. Let's say I have the log of x, y. These are multiplied together, right? So then multiplication is the same as addition. So I can rewrite this as try to stick with the lowercase. It's not crucial, but this then would be the log of x plus the log of y. And this could be any base. You know, this might be base 10. I'll call it right now just base a. So multiplication is the same as breaking it up into an addition problem. Division then, so let's say I have the log base a of x divided by y, then this would become then log base a of x minus log base a of y. And last, thinking about this, if I have log base a of x raised to the power of r, for example, then I can rewrite this. So 2 layers of exponents becomes a multiplication problem, right? The exponent then can come out front. So now this becomes r times, the times there, right? The log base a of x. So here we're expanding it out, or if you want, you could start here and you could go backwards and condense it a bit. So expand or write it more compactly. So these are 3 log properties that we'll end up using to help us solve problems. But at first, before we even get to solving, let's just practice using these log properties, okay? So here I have 2 examples we can work on. What I want to do is expand this using these log properties. And so you can see here's an exponent right up there. Here we have multiplication, which is like addition, okay? So let's write out. So I have log base 3 of x squared times the same as saying plus log base 3 of y. And again, this then can be pulled out front and use it as multiplication. So now we would actually have 2 times the log base 3 of x plus log base 3 of y. So again, we're not solving for anything here yet. This just gives us a tool to manipulate logs so we can solve. So let's do one more example. And this one's kind of a messy one, actually. Do you remember what square root? What is the equivalent exponent? So I can rewrite this as log base 5 of, and the square root is the same as saying I have a 1/2 exponent. And inside I have 2 times x to the 4th over z times raised to the power of 3. Okay, so if we start off by using this log property here, I can bring that 1/2 out front. So I'll just do that. So this is the same as saying 1/2 times, in fact, I'll use some parentheses here, log base 5 of 2x to the 4th divided by z cubed. Now, So we have times here, we have divide here, and we've got some exponents. So let's use the multiplication property, and then we'll use the division property. So I'm just going to leave this 1/2 out front. So I have 1/2 times log base 5 of the 2 plus is the same as saying add log base 5 of x to the 4th. Divide is the same as saying subtract, so I'll do log base 5 of z cubed. Okay, and then one more thing to expand it a bit more is we do have these exponents, so we're going to bring those up in the front. So the final expansion of this, and again, we're not solving here, we're just practicing using these log properties. This is going to be then 1/2 times log base 5 of 2 plus, bring that 4 to the front, 4 times log base 5 of x minus 3 times log base 5 of z. All right. So let me erase this and we'll do a little more practice with using these log properties.